see question number 18. Okay, 198 or something. Please check. Okay, L and M Limited have the risk and return. See, return of L is given, return of stock M is given, standard deviation of L is given, standard deviation of M is given. You understand? Coefficient is what? -1. Okay, -1. Exactly. Can we diversify? Yes, 100% we can diversify. Okay, we can minimize the risk. Calculate the proportion of the investment of M Limited to minimize the risk of the portfolio. Okay, what should be the proportion weights of L and M so that what we can minimize the risk of the portfolio. Okay, so we know when R is -1, this will be the formula. Yes, question number 18. When R is equals to -1, minimum variance portfolio, what they are asking, to minimize the risk of the portfolio. So that is weight of X is equals to standard deviation of Y other upon, okay, since R is -1, the denominator will be plus, yes or no? Okay, what is the standard deviation of, in fact we should use L and M. Okay, if let's say this is L, then this will be M. Okay, this will be L plus M. So variance of M is how much? 15%. 15 divided by 18 plus 15. I hope you are understanding. So answer is how much? 45.45%. Therefore, weight of M is equals to 100 minus 45.45, 54.54%. Okay. Therefore, proportion of investment, please copy, proportion of investment in L Limited is equals to 45.45%. Proportion of investment in M Limited is equals to 54.54%. That's it. Done. Understood? Easy. See the next question. Easy? Understood? Should I move? Okay. Please be quick. These are all very small sums. Okay. So I'm not spending time on that. P and means, listen. If you try to calculate any other proportion here, any other proportion, just focus me on this so that let us spend some time so that it gets into our system. Any other proportion other than this, the standard deviation of the portfolio, okay, will not be minimized. Any other proportion, okay, understood? So if you want now, we can try. Let us give a try. Is it? We will have to calculate the standard deviation of the portfolio when the weight is 0.4545 the whole square into the variance of the first one. L is what? How much is the L's variance? 18. Correct? Okay, 18 square plus 0.5454 square into how much? 15 square plus 2 into 0.4545, okay, into 0.5454, okay, into, right now R is -1, R into, I don't have COV, so I will apply R formula, -1 into 18 into 15. Understood? Give me the answer of the first part, someone. Give me the answer of the second part, someone. And give me the answer of the third part. 66.92. Okay, 9293 plus second one. 66.93. Okay, 93. Okay, next part. 133. It's minus. Okay, minus 133.86. Okay, please add, take the square root. Please add and take the square root. Answer is 0. You remember that at -1 we can reduce the, you remember that theoretical part, you can reduce it to 0. So see, hence proof. Let us, this is just a proof, this is just a proof. Okay, other way around. See, this shows the confidence in the subject. Understood? You should try all these things if you have time, then only. Let's take weight of L as 0.4, and weight of M as let's say 0.6. I'm just changing it. It is actually nonsense to do this, but still the risk will not be reduced to 0. Just I want to show you that. Okay, so standard deviation, I have assumed it. This is assumption, assumed. You can take any other combination anywhere, okay, except that 45 and 54 now. Other than that, any proportion, okay, risk will not be reduced. So let us check. Under root 0.4 square into 18 square plus 0.6 square into 15 square, correct now, plus 2 into 0.4 into 0.6 minus 1 into 18 into 15, correct? Understood? So please see, first part is 51.84, second part 81 minus 129.6, so final answer is 1.8. Final answer is 1.8. See, it has not gone to 0. Understood? So if you want to copy, you can copy. This is proof. Please copy. This is a proof. This is not a part of the answer. Okay.
Thank you for watching.
Please like, subscribe and press bell icon to get notified. Get in touch with us at 9930-666-413. Visit us at www.finhubacademy.com. Connect with us on Insta and Facebook at FinHub Academy.